So today we will learn the third solid principle, that is Liskov Substitution Principle. Let us begin with a common analogy. So here you can see a diagram in which I have taken some super classes which are called base classes, and that is car, bird and fuel. And these are the types or the subclass of the classes which are present above. For example, hatchback, it is a car. It is a subclass and it can replace car. Ostrich is a bird and it can replace bird. Similarly, gasoline is a fuel. It is a subclass and it can replace fuel, which is a superclass. But is this actually true that ostrich is a bird? See, the characteristic of a bird is it can fly, but ostrich do not fly. So, we cannot apply this generalization here that ostrich is a bird. This is what LSP states. It says that objects of a superclass should be replaceable with the objects of a subclass without affecting the correctness of a program. So here I have described it in more detail. A child class should behave like a parent class and there is no surprise in it. For example, if I go back here, like the hatchback class is a car only. So we can say like, okay, it is behaving like a car and there is no surprise in that. Ostrich is a type of bird. No, we cannot make this generalization because ostrich do not fulfill the basic characteristic of a bird. It cannot fly. So, objects should be replaceable with their subtypes without affecting the correctness of a program. But in this case, we cannot replace the objects of ostrich with that of a bird because that will affect the correctness of a program, as birds can fly but ostrich do not have that property. So the key points to remember here are: don't override or inherit in a way that changes the expected behavior. This will be very much clear when we dive into the practical. So without wasting much time, let us go to the experiment. So here let us see. I have created one console application and I have created three classes. The first is the bird class. I have created a fly method in here, and this is printing some statement that is console.writeLine flying, right? I have created one more class ostrich that will implement this bird method. So this is a subclass or a child class for bird, and this is overriding the fly method that was defined in here. I have also created a bird watcher class and it will take an object for bird type and implement this particular fly method. But we should note this point that if this method fly is implemented in the ostrich class, so this will throw an exception. Why? Because ostrich cannot fly. So let us call this method and see what happens. I have put in a breakpoint here, made an object for bird watcher and passed in that ostrich object for the make bird fly. Let us run this and see. So my breakpoint is hitting here. I will go into the implementation. Right, it is calling bird.fly method. I will again go to the implementation. See, bird here is collecting ostrich. This is the ostrich type object. If I again go to the implementation, see, it is coming in the ostrich class and it will throw an exception. So that is what we don't want. Okay, now let us see the correct implementation of LSP. Just to save time, I have already created this test application. I will make a little changes here. I have a bird class wherein I have two methods, fly and an abstract method, eat. This bird watcher class is same. It is calling a method fly for that object bird, But note the difference here. Now it is taking the object of an interface. Let us see what this interface is doing. So this interface is declaring a method fly. Let us have this ostrich class. See, ostrich can eat, but it cannot fly. So if you see this bird, here we have declared a method in fly. We don't implement this method in this ostrich class because we know that it is going to throw an exception. This is one type of bird. If we see another type of bird, what we do, we inherit it from bird class and iFlyable interface. So what we are doing, we are implementing the methods for this uh, for the method that we have declared in the iFlyable. This will be printing this that sparrow can fly, and we have also overridden the method eat for the bird class, right? So one thing which I forgot to tell you is, see, the ostrich is inheriting bird class, but it is not implementing iFlyable. So how do we implement this LSP? What we are doing here, the core is this interface, which is enabling us to keep the method separate so that the subclass is having a feasibility to not implement the methods which is not needed. For example, in ostrich class, we do not need this fly method. Similarly, in sparrow, yeah, we need the fly method as well. Why? Because sparrow is a bird which has all the properties of bird. So the generalization that objects of a superclass can should be replaceable with the objects of subclass perfectly fits here because sparrow fulfills all the condition of a bird. Now let us run this program and see what happens. Now before running this program, see, let us go into the program.cs class. I have created an object for flyable and it is pointing towards the sparrow, means it is containing the reference for sparrow class. Now in this I have passed this flying bird and this contains an instance for sparrow. Everything works fine. Now let us put a breakpoint here and see what happens. It comes in here, it goes here and it calls the fly method. See, it will simply print sparrow is flying. Not a problem. Let's continue running. Okay, I'm sorry. I have not written the statement console.readline, so it won't hold that screen. So anyways, the whole point was here I have created the object for bird class and see, if I do something like this, I call the observe flying method and pass an ostrich. This will throw me a problem, a compile time exception. Why? Because in this ostrich class, we cannot take that fly method that we have used in the iFlyable interface because ostrich class is not inheriting that iFlyable. So there is no point to implement the method fly in here. That is the reason we need to comment this line out of here. Now if I press simply console.readline, console.readline to hold my screen, we can get our desired output. We have to click on save. Okay, let me restart the application. See, sparrow is flying. Okay, so that is what LSP states. That's it for this lecture. If you have any doubts, please mention them in the comment section.